Today's problem. Given a weighted directed graph, okay, we are given a weighted directed graph with n nodes and m edges. Nodes are labeled from 0 to n minus 1. The task is to check if it contains a negative cycle. So we are dealing with negative weights. Like we know there are different like there is Dijkstra's algorithm in order to find the shortest path. It's the shortest path algorithm, but there we are not dealing with negative weight cycle. There we are dealing with positive weight cycle. So what's dealing with negative weight cycle is Bellman-Ford algorithm. So this is nothing but applying Bellman-Ford algorithm. So how we will be doing the Bellman-Ford algorithm? So Bellman-Ford algorithm generally is used in graph that is having negative weights, okay, which contains negative weights. We all know Dijkstra's cannot be applied for negative weight, but Bellman-Ford is the algorithm that we are making use for negative weight. So how we are going to do this Bellman-Ford? So the initial steps for the Bellman-Ford is we will be having a distance array, okay, a distance array which will be everything infinity, a very large value, except the source node, which will be setting it as 0. Okay, let's say we are having some graph, there is some, okay, and this is the source, and the distance to this source will be 0, and to all the others are considered infinity. So that's the first step. Next we will be doing a relaxation step. We will be doing a relaxation step. So what is this relaxation step? So relaxation step is nothing but we will be updating the distance of, let me write, we will be updating the distance of destination equal to distance of source plus the weight whenever our distance of source is not equal to infinity and distance of source plus weight is less than distance of destination. So whenever this condition arises, okay, we will be, this is what we call it as a relaxation step, and this relaxation step will be done n minus 1 number of times. Okay, so after doing this n minus 1 number of times, we will be getting our distance value, distance array updated. All the values will get surely updated. Okay, and we assume like that's the smallest distance that we can take from a particular node to some other destinations. Now in order to detect the negative weight cycle, we will be doing this relaxation step once more, and after doing that, okay, if we are able to find any source or destination that changes any of these values, because after finding this n minus 1 number of times, after applying the relaxation step n minus 1 number of times, we will be getting the array which is the smallest. Okay, there is no other way that we can change it. So in order to make it so, even if we do more number of relaxation steps, it should not change. But if it gets changed, that means there is a negative weight cycle which makes our distance keep on changing and changing and changing. So that's the place where we'll be saying that the given graph is a negative cycle. Otherwise, it's not a negative. So let's look for this. So we are having an edge from 0 to 1. Okay, we are having an edge from 0 to 1. Okay, and its weight is minus 1. Okay, its weight is minus 1. Now we are having another edge from 1 to 2 and its weight is minus 2. So 1 to 2 and its weight is minus 2. So we will be having the distance array. Okay, and let's consider this as a source. Let's start our operation from this and let's say that this is the destination. So this will be 0 and the rest will be infinity, because there is only 3 nodes. So 0, 1, 2. Okay, now what is our relaxation step? Our relaxation step is, let me write that once more, d of source plus weight is less than distance of destination. When we will apply this? If okay, equal to yes, if this holds, and one more condition, d of s should not be max value or infinity, then we will be updating the destination as with the smallest value. This means for a particular destination distance, we find another distance from this source by making use of this weight. So that's a smaller value, so we'll be updating that destination. So let's start from here. So this is the condition that we'll be checking. So if is this source, so what is the distance of source? Distance of source is 0. So is 0 plus what is the weight? Minus 1. Okay. So one more time, how many times we will be doing this? 1, 2, 3. N minus 1 number of times, where n is the number of nodes. So it will be 3 minus 1 number of times, which is equal to 2. Okay. So initially we will be doing 2 number of times. Then again we just check it again whether any of the values inside this array gets changed. If it's changed, that means there is a negative weight cycle. Otherwise we are good with our graph. There is no negative weight cycle. So let's continue. So 0 plus minus 1 is less than infinity. Sure, it's definitely less than infinity. So we will be updating this value to minus 1. Okay, now we reach this position. Okay, now we are at this this node. Okay, so what's that? Is distance of 1. What is the distance of 1? Distance of 1 is minus 1 plus the weight minus 2 is less than distance of destination. What is the destination? It's 2. So this is our adjacency list will be 0 to 1 and 1 to 2, and we are considering this place as the source, this place as the destination. So now we are at here. So distance of source plus weight. What is the weight? Minus 2. So distance of source, this we can get from our distance array. Minus 1 plus minus 2 is minus 3. Minus 3 is less than infinity. Okay, so this value gets updated. So this is minus 3. Now we are fine. Now we need to make sure whatever value we get here are the smallest distances, are the smallest values possible. If in any of this place the value gets updated, then we can say it's not true. So now once again, like we will be doing the relaxation step. We done n minus 1 number of times. Now we will be again doing the relaxation step once more. So again, distance of source 0 plus weight minus 1, okay, is less than minus 1. 0 plus minus 1 is minus 1. Is minus 1 less than minus 1? No. Okay, now this place, okay, is minus 1 plus minus 2 is less than minus 3. No. Zero plus minus 1 will be minus 1. Yes, that's fine. And okay, distance of minus 1 plus minus 2 is minus 3. We again start from here. 0 plus minus 1 is less than minus 1. Is minus 1 less than minus 1? No. Okay, is minus 1 plus minus 2 less than minus 3? Minus 3 is less than minus 3? No. So we are fine. So 0, 1, 2, 0. Oh, I miss one more. Yeah, this okay, so this will not be a cycle. This will not give a cycle because we are not able to change this value. Okay, That was a mistake. I thought of doing this. Here it says this is a negative weight cycle, but we only considered these values. Now let's update our graph with this value and do this process once more. So we are also having a 2 0 minus 3. So we are also having a 2 to 0. So we are having a source here and a size minus 2. So now we are having now we are having again three nodes. So our relaxation step will be n minus 1 number of times. So it will be 3 minus 1, which is equal to 2. And whenever our ds of s, the distance of source, is not equal to the maximum value, and distance of source plus the weight is less than distance of destination, then we will be updating it. So once again we are having this. Okay, so our source, we start from 0. Well, let's have that value is 0. Then we have 1 and we have 2. Okay, this is infinity and this is also infinity. So what's the step? Is d of s equal to max? No, it is not equal to max. Fine. What is distance of s? Distance of 0, we are starting from here. Okay, distance of 0 is 0 plus what is the weight? It's minus 1. Okay, minus 1 is less than infinity, sure. So we'll be updating this value. Okay, minus 1. Okay, now again now we are at this position. Okay, this is the first iteration. Okay, this is the very first iteration that we are doing. So now from 1 to 2 we are having minus 2. Okay, so distance of 1 is minus 1 plus the weight minus 2 is less than infinity. Sure, it's less than infinity. So we will be updating this value with that sum, distance of source plus weight, which is minus 3. Okay, that is also fine. Now from 2 to 0 also we are having. So what is the distance of 2? It's minus 3. Okay, what's the weight? It's minus 2. It's less than 0. Yes, it's less than 0. That means minus 5. So this value will be updated as minus 5. So now we done one relaxation step. Okay, now we are going with the second. Okay, we are going with the second. So for the second also, like the same condition, our distance of source should not be the maximum value, and our distance of source plus the weight must be less than the destination. So what is the distance of source here? We are again starting from 0. Okay, so it's minus 5. What is the weight? Minus 1 plus minus 1. Is it less than? Distance of destination is 1. Is it less than minus 1? Yes, minus 6 is less than minus 1. So we will be updating this as minus 6. Okay, perfect. Now we are moving to this one. Okay, from 1 to 2. So source is 1, destination is 2. What is distance of 1? Distance of 1 is minus 6. Is get updated. So minus 6 plus, what is the weight? Minus 2. So minus 2 is less than minus 3. Sure, yeah, minus 8 is less than minus 3. So our this value will be updated to minus 8. Now we are also having one connection from 2 to 0. So what is the distance of 2? Distance of 2 is minus 8. So minus 8 plus the weight is minus 2. Minus 2 is less than distance of 0, minus 5. So minus 10. Minus 10 is definitely less than minus 5. So this value gets updated to 0. So now we have done the two relaxation steps, and minus 10, minus 6 and minus 8 are the values. Okay, considering from this source, these are the smaller distance that will be possible, like we are assuming, or we got this distance array. Now in order to make sure that there was no cycle, we will be doing this relaxation step once more. And if this values gets affected, then we see before the previous example, the values didn't get affected. So the same way here, if the value gets affected, then it means there is a negative cycle. So we again start from here. Our third, the extra relaxation step that we are doing to confirm that there are no negative weight cycle. So distance of source, what is the distance of source? -10. What is the weight? -1. Is it less than -6? So -10 plus -1, -11. -11 is less than -6. But if it doesn't contain a negative cycle, this value, this -6 should not change. But what we got, after doing one more relaxation step, we get -11 as a new distance, and it is less than -6. So that means there is a cycle, a negative cycle, which is happening here, which keeps on changing our distance. So this means there is a negative weight cycle. So that's only what we need to do. So why we are doing n-1 number of times means, like doing n-1 number of times, we will be able to update the distance array of all the nodes. So consider like we are having a simple graph A to B to C, okay, and we are having the adjacency as B to C, we are having an adjacency as A to B, and our distance array, okay, our distance array will be like 0 for A, infinity for B, infinity for C. Perfect. So we need n-1 number of steps. So here 3 nodes, so there must be 2 number of reflections. So this will confirm that all the values inside the distance array gets updated. So if we start from B to C, so B to C, here B's value is maximum. So one of the condition for the reflection or the step is, reflection step is like the value, the distance value should not be 0. The distance of source should not be maximum. Sorry, not 0. It should not be maximum. But here it is maximum. So we will not be able to update it. Now we are having A and B. So A is having 0. So 0 plus any weight will sure be, there will be some weight, say weight 1, weight 2, some weights. I'm not fully going for that. So this will surely be less than this infinity. So this value gets updated. This value will get updated with some value, say y. Okay. Now next time we are doing for the next reflection step, we get B. So we get the value for B. So y plus, there will be some other weight, weight 2 will surely be less than infinity. So we will be also able to update this value to some value set. So that's why like we will be doing n-1 number of reflection steps. And if we do again, this value should not change if there is no cycle, and its value changes if there is a negative cycle. So that's only the logic. And this algorithm is pretty common in graph algorithms. It's a Bellman-Ford algorithm. So if there is no graph, if edges is equal to null, or n is equal to 0, let's say if it is 1 means there is a cycle. So no cycle, no graph, nothing. So our relaxation step, sorry, I just I set a reflection step before, but it's a relaxation step. So we need to do n-1 number of relaxation steps. Yes. And before that we need a distance array which is of the size of n, and all the values will be filled with the max infinity. So here integer dot max value except the source node. Here I am considering 0 as the very first node or the source node, and you will be having a value 0. Perfect. Now for int I is equal to 1, I less than or equal to n-1 number, I plus plus, we will be going through each of the edge from edges. So edge of 0 will be the source. So source is equal to edge of 0. Edge of 1 is the destination. So destination is equal to edge of 1 and weight is edge of 2. So that's what this values. This is source, this is destination, and this is the weight. Now our main relaxation condition, the condition. Okay, what is the condition? Our distance of the source should not be max value, and at our distance of source plus weight must be less than distance of destination. If such conditions becomes true, then we will be updating the distance of destination is equal to distance of source plus weight. Okay, and this steps goes for n minus 1 number of times. Now we will be having the shortest distances, the smallest distances from the source to all other nodes by making use of some weights. Okay, and this should not change. It gets changed only if there is a negative cycle. So we can do once more. So we will be doing once more. Relaxation step once more to make sure about the negative cycle. Okay, so we will be doing this once more. Edges, let's take all these values again. Edge of 0, it's always good to take all those values, edge of 0, edge of 1, edge of 2 into a variable, and then make use of that variable later. Int destination, because if another person who is viewing our code, he will not be knowing what is edge of 1, what is edge of 2, what is edge of 0. So we just specify it. Edge of 0 is source, edge of 1 is destination, so it will be pretty clear. So edge of 2. Now once again, if distance of source not equal to integer dot max value, and at distance of source plus weight, let me bring it down. Okay, weight is less than distance of destination. If that condition again satisfies, that means there is a negative cycle. So return 1. There is a negative cycle. There is a negative cycle as distance will get updated. Otherwise we will be returning 0. So what will be the time complexity? We are doing this n minus 1 number of times, and we are going to all the edges. So let's say if it is, this is of size n by 3, so it will be n into whatever be the edges. So n into e. E means edges. So e means edges, and space complexity, like we are making use of extra distance array, so big of n. So the time complexity will be big of n into e. E means edges. Okay, because we are considering all the edges here. So wow. Like once more, let me look that animation here. It first increases, then it decreases. Oh, now it's fine. So that's our algorithm. This is nothing but, if we have negative weight cycle, let's apply a Bellman-Ford algorithm. It's nothing but straight away applying Bellman-Ford algorithm. So that's the problem of the day.